Alrighty, so we are going to talk about topic 4, parallel and perpendicular slopes. However, I thought I'd actually give you a warm-up, so if you haven't already, you can go to your warm-up page and put this in there. The two questions are, what does parallel mean and what does perpendicular mean? So parallel, hopefully remember that from years past, is when two lines never intersect, okay? They are going to go on and on and on forever and never ever touch. Perpendicular is when you have two lines that intersect with a right angle, 90 degrees. Okay, so yes, these are kind of like opposites because in one case they never touch and in one case they touch the right angle. But we really have to have a grasp on that before we can even understand remotely what we're doing today. So again, parallel, lines never touch. You can kind of look at these two L's in the word parallel for a reminder of that. And then perpendicular is when they meet at a 90-degree angle. So our objective today is to be able to identify parallel and perpendicular slopes. Hopefully you've already checked your homework in Schoology and taken a teach check, and then we'll do our notes. So right off the bat, let's just plot these points on the graph and connect them to make a triangle. So negative 4, 1, negative 2, 4, 4, 0, 2, negative 3, which again, you'll have to forgive me and my board. You know how it goes. Hopefully yours is much prettier. I'm going to put right angles so that it, somewhat looks like it's a rectangle. Okay, there's our rectangle. I forgot to label A, B, C, D. So now what they want us to do is determine the slope of each of these little line segments. So side AB, if I was to do rise over run, I would rise 1, 2, 3, and run 1, 2. So 3 halves. Side BC, I would rise 1, 2, 3, 4, and run 1, 2, 3, 4, 5, 6 in the negative direction. So 4 over negative 6 would be negative 2/3. Side CD, again, my rise, my run, 1, 2, 3, run 1, 2. Inside DA, rise 1, 2, 3, 4, run 1, 2, 3, 4, 5, 6 in the negative direction. Okay, some of y'all can already, at this point, very beginning of the notes, tell where this whole lesson is going. But we have our slopes there. AB would be 3 halves, BC is negative 2/3, CD is 3 halves, and DA is negative 2/3. We have some similarities here, right? So it says compare the slopes. What do we notice about AB and CD? So AB is here, CD is here. 3 halves, 3 halves. Obviously the slopes are the same, but let's look at the lines. AB and CD. Here's AB, here's CD. Well, this is a rectangle. We know that those lines are parallel. So what do you notice about the lines and slopes? Parallel lines, same slope. They're both 3 halves. Okay, then they want us to compare BC and DA. Okay, so BC, DA, let's scroll down here. BC, DA, negative 2/3, negative 2/3. Well, and again, BC is parallel to DA. So same thing, parallel lines, same slope. Okay, so now we're switching gears a little bit, CD and DA. Okay, let me erase this real fast. CD and DA, so that's the bottom two down here. 3 halves and negative 2/3. Okay, that's interesting. Looking at my picture, it's these two, CD, DA. Those meet in a right triangle. In a right angle, sorry. So CD and DA, think about our warm-up, those are perpendicular. Perpendicular, I got a little crazy there. And their slopes are different, right? But not just different, they are opposite signs. One's positive, one's negative, and reciprocals of one another. Okay, one was 2/3, the other was negative 3 halves. I bet you can already tell where the next one's going, AB and BC. Those are also perpendicular, and their slopes down here are also opposite reciprocals. fact, just for saving time, I'm going to do this. Those little quotation marks mean the same thing as above. So just looking at this rectangle, we can already kind of decide parallel lines have same slopes, which makes sense, right? Slope just means the steepness. So if a line is this steep, we want a line that is parallel. It's the exact same steepness. It'd be the same slope. Okay? Perpendicular lines have opposite signs, and they are reciprocals of one another. Okay? What's special about that is that if they're perpendicular, then the product of their slopes is -1. And we can prove this with that first example. 2/3 times -3/2. Is it the other way? Is the negative on the 2/3? Oh, negative was on the 2/3. Sorry. There we go. When I multiply this, top times top, straight across, I get 6/6, and one was negative, one was positive. So -6/6. Well, that is -1. Okay? The rest of this thing goes super quick because you're just following that same rule over and over and over. So number 3, what is the slope of the line? Well, it's a graph, so I need perfect points. Got one there and there. So I go up 1, 2, 3, over 1, 2, 3, 4, 5, 6. That means my slope would be 1/2. So what is the slope of a parallel line? Well, we just learned that they're supposed to be the same, so 1/2. What would be the slope of a perpendicular line? Well, it's supposed to be opposite signs, so negative, and a reciprocal, so 2/1, or just -2. And then it says check the perpendicular slopes. Well, that means if I take 1/2 and multiply it by -2/1, do I get -1? Sure do. Okay, check. Next problem. Given the table, what is the slope? Well, again, a table, those are easiest if we just do our little loop-de-loops here. -3 to 1 would be +4. 1 to 6 would be +5, but we know that that's okay. +5 again. 28 to 12, that'd be -16. 12 to -8, that would be -20. -8 to -28, that'd be -20 again. So if I turn these into slopes, I've got -16/4 or -20/5. Either way, both of these equal -4. So the slope of this line is -4. So the slope of a parallel line, -4. Slope of a perpendicular line, opposite signs would be a positive this time. You don't really need to write the plus. And then flipped over. Well, how do you flip over a whole number? Well, I know that -4 is really -4/1, right? Now that's flippable. I flip it over, so 1's on top, 4's on bottom. So a +1/4. So to check, I do -4 times 1/4. A fourth of -4 is -1. Okay? Now 2 points. This gives us a chance to review yesterday's lesson, right? x1, y1, and x2, y2. My slope formula is y2 minus y1 over x2 minus x1. So y2 would be 14 minus 8 over 4 minus 2. So that gives me 6/2, overall slope of 3. Okay, I'm going to give you a second. I feel like I'm on Blue's Clues, where I wait for you to yell the answer at the screen. So what would be the slope of a parallel line? 3. Very good. It's the exact same thing. What would be the slope of a perpendicular line? -1/3. Good job. So we changed the sign, right? So it was a positive, but now it's a negative. We flip it over, and you can flip a whole number. You just put a positive, you put a 1 underneath it. Okay, last problem. Given the graph to the right, what's the slope of the line? Well, I noticed that this is a horizontal line. Well, horizontal starts with the letter H, which makes me think of hoi. The O in hoi reminds me that the slope is 0. So if I want a parallel line, well, I know the slope's supposed to be the same, another 0, which makes sense because another parallel line would be another horizontal line, another hoi. But then they say, what about perpendicular? Well, it's kind of hard to flip a 0 over, but again, I can just think about this. Perpendicular to a horizontal line would be a vertical line. Well, V makes me think of VUX, and I know that the U is undefined. Okay? Then here's just two random questions just for funsies. What axis is parallel to that original line? What axis is parallel? The x-axis, right? To a horizontal line, supposed to be parallel. What axis is perpendicular to the line? Well, the y-axis. Okay? Alrighty, that's it. It's like one of the shortest videos you're going to have all year. There's no TEKS checklist item for this individual thing. This is just kind of like a fun little random thing to throw in. There. But parallel lines have the same slope. Perpendicular lines have opposite reciprocals. You can kind of just mentally fill out a checklist in your brain of, did I get this green? Am I kind of okay but not totally yellow? Or am I completely clueless and need to stop by for tutoring red? Let me know when I get back on Monday what questions you might still have, but still attempt the homework, try it to the best of your ability, and bring that on Monday ready to go.